We're going to take a look at inequalities with two variables. Remember, inequalities means we're not having an equal sign. We're having some sort of greater than or less than or equal to sign. We've done these earlier in the year. So, for example, if you had to graph x less than 5, you go to your trusty number line and you shade all the numbers less than 5. And then you take a look at this because it didn't have the little line underneath to say less than or equal to 5. Then you do the open circle so you don't include 5. At that point you might be asked, is x equals 3 a solution to this? And there's two different ways to think about this solution. First of all, is 3 in the shaded region? Well, if it's in the shaded region, then we know it's a solution. That's probably the easiest. But another way is to take the 3 and plug it into this very, very simple inequality. So x less than 5, 3 less than 5. Is that a true statement? If it's a true statement, then we say yes, it is a solution. So these ideas of a graph and then how to determine if a point is a solution in your inequality are going to end up being parts of the next units or the next sections that you do. And of course, we could have picked a number instead of 3 that is not a solution. X equals 10 is not a solution. I can do it by plugging into the inequality. X less than 5, plug in the 10. Is 10 less than 5? Heck no. If I say false, then it's not a solution. Or the other thing would be just literally look at your shaded region. Does your shaded region include positive 10? It does not. So then you would also conclude not a solution. So now we'll move forward to the new stuff. What we did before were inequalities with one variable, just an x. The new stuff is going to have x and y variables. And for today, we're just concerned about determining if an ordered pair is a solution to that inequality. And by the way, for this first example, I have x equals 2, y equals 4. Remember that you can always write that as an ordered pair, 2, 4. So if I want to know if it's a solution, the two methods we had in the review were look at the shaded region or plug it into the inequality. Looking at the shaded region is going to come up in a future lesson, so all we care about for today is plugging the 2, 4, x equals 2, y equals 4 into the inequality and finding out if we have a true statement. So you'll notice that I've done it here. I take the original inequality, I plug in, I do the math, and I come up with a true statement. 26 is greater than or equal to 20, so that means 2x equals 2, y equals 4 is a solution. Or I could say the ordered pair 2, 4 is a solution to that inequality. Over here on the right, you see a 4, 1, and I could have said that's x equals 4, y equals 1. And I want to know if that's a solution. I take my inequality, plug in the x and the y, I work out the math, and is 17 greater than or equal to 20? It's false, so that means that ordered pair or that x and y value are not a solution to that inequality. We'll add on to this with a graphing method later, but for now, that's all you need to know.